Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is driver comfort systems, operation, and testing. So I took this as these are things that are in a vehicle that are nice to have, but you really don't have to have them to operate the vehicle. So things such as heated and ventilated seats, heated steering wheel, noise canceling systems. They actually have systems in the vehicle now to cancel out any outside road noise or engine noise. And then we have the opposite side of that, which would be sound generation systems. So those are things that they use on electric vehicles and hybrid vehicles to generate a sound so people can hear them coming down the road since they don't have an engine noise. And then also electronic motor mounts. Many vehicles have electric motor mounts now, and they need them to stop vibration. Big one's Honda that uses that since they have a cylinder kill. So if they kill 3 of the cylinders while you're driving down the road, it's going to be running on 3 cylinders, and it might not be that smooth. So the electronic motor mounts help to steady that a bit. So with that, first up, we'll talk about heated seats. Now, heated seats, pretty common, been around for a while. I think the majority of vehicles probably nowadays have at least an option for an electric seat heater. I suppose if you live in the desert, you probably don't need it, but up where I live, up in the Northeast, it gets pretty cold. So it is nice to have a heated seat. It is a heater element in fabric. So what you're going to find is, think of like a toaster. Similar in an idea. You're going to have an element, a filament, and depending on the amount of current that flows through that filament, we'll give it a different amount of temperature depending on the amount of current flowing through. Usually the seat and the back are separate. Sometimes they can kind of be tied together in one piece and just have a couple little pieces that tie them together. And nowadays they can be found in the front and the rear seats. So we could have rear seats. I was in I think it was a Buick the other day, and it had heated seats all the way back. All 3 rows had heat options. So I thought that was kind of interesting because it only used to be, not that long ago, heated only in the front, right? So we have that option. Now, when they're going to fail, usually it's going to fail maybe kind of partway through. I know on Subaru, there was like a resistor in there that would always tend to pop, and you find a little burn spot on the padding that it had. But it can overheat, and suppose if it's bad enough, it could cause a fire. So we want to be definitely careful with that if we suspect there's any problems with it. But fairly simple to diagnose too, especially if you have, say, a thermal camera. So if you have a thermal imager, we look on the right-hand side, that's a good one, and you can see the filament going through the seat there. So this would be underneath the cover fabric, and then it's another fabric layer inside underneath the padding and underneath the cover there. And we can see how flat these wires are, and they just kind of sit in there. And they heat up the more current that flows through them. It's a little metallic element, like I said. And then the bad one over here, we can see we don't see the element at all. We just see the seat kind of sitting there doing its thing. And we don't have any hotter spots like we have with these squiggly lines. So that's fairly easy to diagnose. And then all I got to do is check it electrically. I can check resistance, continuity, Most times there isn't going to be a separate module. Some of the more complex vehicles, it might be a module, but pretty often it's going to just be a relay and a switch, a couple wires. It's not going to be terribly complex with that, right? So definitely not that difficult to work on, not that difficult to diagnose. Oops, wrong button. There we go. Next one's going to be ventilated seats. So we take the heated seats and we do the opposite. We cool them. So what these do is they use fans to push or pull air through the perforations in the seat. So very difficult to make an actual chilled seat, something that's cooled off, at least for a decent amount of, low cost, and to make it so you could sit on it and not feel it through the fabric, because the more padding you're going to put on there, the more insulation you'll get. So then the cooling effect won't even make a difference at that point. So they use fans, and they either push air, so you'll feel it blowing on your back and on your legs as it goes through the seat, or some manufacturers decide to do it the other way and pull the air through the seat and push it out the back or the bottom. So that way it's able to remove the heat from your body and just kind of in a pulling action, kind of wicking that air, that heat away. Here's just a little closer look on this seat. So this seat's got a couple other things going on in there. We got a module in there, but there's the fan. You see, it's kind of a thin line, almost like a computer fan, and then some ducting that goes through. And then also in this case, we have a heated seat as well. So there's your seat heater pad. And in this vehicle, it'll also blow it through the seat heater to blow warm air out through the seat as well. So it just kind of depends on how the manufacturer has it set up. Sometimes it'll do a little bit of both. Sometimes it'll do just the cooled and just the heat. It just depends on how the manufacturer does it. This one also looks like it's got a lumbar adjustment as well, electronic one. So we've got a little pulley system right there, an electric motor. So that'll make it go out and in. So a little lumbar adjustment. So there's another thing that's kind of a nice to have. We're really not talking too much about it in this session, but another nice to have. And also heated steering wheel to go along with the heated seats. Nice to have, not necessary for operation of the vehicle, but boy, it makes it nice, especially when on a cold day, it can get below zero. That's a very nice thing to have, a nice warm steering wheel when you're out. Once again, don't really have the cooled option. Haven't seen a cooled steering wheel. I bet you could probably do that with a fan as well. That might be one of those nice $1 million ideas you might come up with, right? It's for the cooled steering wheel on those really hot summer days where you're burning your hand trying to steer with it. So on the heated steering wheel, though, it uses a very similar element, just like on the seat. You can see the filament right there. It's just kind of just a computer generated cutaway from a heated steering wheel manufacturer. So you can see it go through there. And once again, easy enough to diagnose if we have a thermal imager. We can go through here and see, well, there's the temperature going on with the element there, and there's a little break there. I think that's probably where the connector is, and probably the seam on the wheel as well. So that is your heater element around there. You see it gets up to 112 degrees. Nice and toasty for the hands on the cold days there. So once again, that's going to be very similar to how they do the heated seats. So relays and switches. Not usually a module involved. Sometimes there can be. Most times not. Next one's going to be noise cancellation system. So we know driving down the road, you can get a lot of road noise and other noise in the vehicle. So what this does is it uses microphones in the front and the back of the vehicle, takes in the sound that's in the vehicle, and then it plays back a sound out of phase with the original sound. So it's a complete opposite phase. So as we're seeing the sine waves, I actually got a graphic here. So as we see the sine waves, because all sound is a wave. So you can see it go up and down, up and down, up and down. And then the anti-noise, which is the opposite of that, out of phase, is going to be down, up, down, up. So where the valleys are in this, the peaks there in this, and they cancel each other out. And it gives us a much quieter noise in the vehicle. So if this malfunctions, you would obviously hear noise in the vehicle. It could also maybe you hear some static or something like that. Utilizes the radio, so a microphone and the radio. And one of the manufacturers I read up on that how they do it is the radio is always on. Even if you're not listening to anything, any music or anything, it is going to always be on, so this system works. So it plays back through the speakers in the vehicle using the amplifier and all that. So that's how it cancels out the sound. So the sound makes one wave, we make an opposite wave going the other way, and then it really reduces the noise. It really cuts it down, cancels it out. Then we have the opposite idea. So instead of canceling out the noise, we're going to make more noise. So we have sound generation systems on vehicles now, mainly going to be on your hybrids and your electric vehicles, especially electric vehicles, because they don't have an engine to make noise at all. So it plays some form of audio. There really isn't a standardized audio that it plays. So some manufacturers are different. Plays audio to alert pedestrians of a moving vehicle. So think like blind folks trying to cross the street or something like that. They want to be able to hear that vehicle approaching. So the industry came up with a standard for that, and commonly called acoustic vehicle alerting system. Other manufacturers can use other naming for it. Usually it's marketing involved, but it's been mandated in Japan, started there, and it was mandated since 2010. Europe, it was mandated in 2014. The US passed the law or the standard in 2014, but it didn't have to take effect for 5 years till after the law was passed. So when that happened, that was 2019. So basically any year 2020 model year and newer vehicles would have that system equipped with it. Must come on below 18.6 miles an hour or 30.6 kilometers an hour for those who use the metric system there. Anything over that, they basically said, is going to be where your wheels and tires are going to make enough noise where they're going to hear the vehicle approaching at over 30 kilometers. I guess that makes sense. So most manufacturers, it's around 20 miles. Manufacturers use various tones and sounds. So we actually have one of them here we found on YouTube here. So this is a Nissan Leaf. So this is by the Nissan Leaf owners group there. So let's just listen to the sound. It's going to make two sounds. It's going to make the approaching sound and then the backing up sound. So it makes sounds under two different conditions. They call it vehicle sound for pedestrians, or VSP. Almost sounds like a jet engine there, right? And that definitely sounded like kind of a warning tone. It was a sound a little different than your usual used to back up on a truck, right? Or it's like a dump truck backing up or a big rig backing up. You hear that, but it's a little bit different. So that's how they decided to go on. I know I was watching a video the other day. A guy's got a Kia, and he actually lets you change the sounds that come out of it. I don't know if it was necessarily in cabin or out of the cabin with that. They had 3 different built-in sounds, and they could customize it too. So I guess people just need that audible feedback from the vehicle driving down the road. Kind of sounded like a Jetsons car in one way. But hey, they're out there. The electric vehicles are there. So that is something that needs to be done to protect pedestrians. I could probably go through a few more other classes and topics on what they do to protect pedestrians. There's another one Chrysler uses on their minivans, that if it ever contacts a pedestrian, there's an airbag that kind of comes out of the hood, and you have to reset the hood latches after you fix everything. So it's kind of like almost an airbag that comes out of the hood there. Protects people if you hit them. Try not to hit them would be a good way to do that. But if you do, that's it. It's something to protect them. And then in this case, this is something to alert, especially blind folks, if the vehicle is approaching. So trying to cross the street, if they can't hear the car, that's obviously a dangerous thing. So Nissan actually worked with like one of the federations for the blind or what have you, one of those organizations, and other blind people and so on to come up with a tone that would be not necessarily displeasing, but at least I know that a vehicle is coming and I can be alerted to that, that there's a vehicle coming down the road. So in this case, it's got a couple speakers attached underneath the bumper there. Just kind of depends on how the manufacturer has it set up. And that brings us to active motor mounts. So they've actually been around for a little while, probably like at least 10 years with these. They first started off vacuum operated, and then they went to electronically operated. There's a few different styles you might see out there, but it's used to reduce NVH in the engine. So NVH would be noise, vibration, and harshness. So any sort of poor idle quality or anything like that. Or like I said, with the Honda, this is a Honda mount right here. So with the Honda, when they have their cylinder kill for fuel economy and they kill 3 of the cylinders on a 6-cylinder, that's another aspect that they use to keep it from making the car vibrate too much. But if I have a drivability problem, I need to be able to deactivate these somehow to be able to see how's the vehicle running as well. So there are some scanner functions we're going to get into in the live portion. So the early version, this is one from Toyota. And like I said, they started using them probably like 10 years ago or so. ECM controls a vacuum switching valve, which takes vacuum out of the vehicle. And then it, depending on how much vacuum it allows into the engine mount, it'll get softer or harder, depending on how it's set up. So it's able to adjust the firmness of the engine mount using that vacuum and the vacuum switching valve. To get even fancier, that's the Toyota one. So you can see there's the actuator there, they call it, or the mount there. So it's going to monitor multiple signals on the vehicle, and it's going to put out an opposing signal. So kind of like that audio, where it puts out an opposing audio wave. In this case, it puts out an opposing vibration to the vehicle. So it sends a current in here through the coil, and it moves this plunger up and down. The plunger pushes on this diaphragm, which makes the liquid harder or softer. It's kind of like a gel. And if it's harder, it's stiffer. If it's softer, it's less stiff. Had a couple people mention in the last class that, yeah, they've seen leaking active motor mounts cause a misfire code because it comes out, but I guess it doesn't realize that it's bled out, and the engine will vibrate, and it'll just sense the engine vibrating, and it'll say, oh, it must be a misfire. So they've seen that happen with these motor mounts. So we got the plug there, and then we got a coil of wire, runs like an electromagnet, and we got the plunger that moves up and down and pushes on this diaphragm, which pushes on the liquid, makes it harder or softer. So there's just another look at that mount there from Honda. You can see we got the connector there, rubber on top, rubber on the outside. You really wouldn't know unless you saw that plug right there that it was anything different than a regular motor mount. And then we get to Audi. So Audi's a little bit different, and theirs almost looks like a speaker. If you've ever seen the internals of a speaker with the magnet and the coil, it looks like it's going to work in pretty much the same way. It's going to send out generated frequency to offset the vibration of the engine using magnets and coils. So it's basically like a speaker. It's not a speaker, but it's like a speaker. We got a fluid chamber in there as well for dampening, and it pushes on the diaphragm up and down. So really, for all intents and purposes, if you think about it, it's basically a speaker, but it's not. It's a motor. Go figure. So we're using electromagnets to keep the vehicle engine steady and reduce the vibration for the end user, which, that's nice to have. It's not necessarily necessary to have, but it's nice. So that's it for my theory and stuff, an overview. Let's get into some actual vehicles and see what we can see. So first one I want to do is I want to load this Honda Pilot. This Honda Pilot has the active motor mounts. So I'm going to go into Shopkey first and see what we can find out about. It's going to load my vehicle up, log me in, brings me to my landing page. Now I'm going to search for active motor mounts. There, and active engine mount right there. And we can see we have a whole bunch of information on these mounts. I'm going to look first at the TSBs because that's where you should look anyways at first. Rear engine motor mount chirps. You will hear chirping in the cabin with the engine running, the transmission and driving the engine at operating temperature. Possible cause is an issue with the rear engine mount that can cause internal components to wear prematurely. This may cause a chirping once the engine warms up. Do the diagnosis, and based on the results, replace the rear engine mount. So it's going to give us part numbers and such, and then it gives us a diagnosis procedure. This is kind of interesting. Start the engine and make sure it warms up to operating temperature. Put the transmission in drive and apply the parking brake. Place a stethoscope or a long, thin screwdriver on the airbag mounting bolt and listen for a chirp. It must be because it kind of ties it to the column, and the column must be near where the problem is, I guess. If you hear the chirp from the engine mount, go to step 3. If you hear a chirp coming from a high pressure fuel pump, refer to this bulletin. So there's another TSB on another chirp. You hear a chirp coming from the timing belt, refer to this bulletin on timing belt chirps. So there's lots of chirping going on, apparently, on these Honda Pilots. If you don't hear a chirp, this doesn't apply. If we go down there, it tells us remove the heat shield. There's your mount. Disconnect the connector. Disconnect the bolts from the mount. Reinstall the mount in the reverse of the removal, and you're good to go. So that's kind of interesting. There's so many chirps on a Honda that could be that they give you 3 different bulletins for 3 different possibilities. Kind of interesting. But if that's what the customer complaint is, hey, it's making like a squeaking noise or a chirping noise, check that TSB and help you out. Top repairs, OEM testing, component operation. So the active control engine mount system reduces the amount of engine vibration which is transmitted to the passenger compartment. The ACM system consists of the engine mount actuators, the engine mount control unit, and the PCM. PCM receives the engine vibration signal from the crank sensor and the cam sensor, then sends a signal which is in phase with the predicted engine vibration to the engine mount control unit. The engine mount control unit sends current for driving the ACM actuator to the actuator and opens the plunger to reduce the amount of engine vibration. And then there's the graphic we had earlier in the PowerPoint. Wiring diagrams. Let's pull up some wiring diagrams. So first diagram comes up. You'll notice it's on page 2 of 9 because that's where my active control engine mount relay is. So if I open that wiring diagram, you're going to see that right there. And then if I go to the next one, we'll see that my wires are highlighted for my actual engine mount. So I can zoom in a little bit. Use this eyeball to dim the other lines, and I can see there's just a couple little actuators. So it's just showing a coil right there, and it's just positive and negative. So easy enough to test. Power and ground pretty much. And we're just going to have a amount of current flowing through depending on what we need. And then the engine mount control units right here as well. So we have all that kind of in one place. Right side of the dash is where that is. You actually have to pull the glove compartment to get at that control module. But it looks like a fairly simple system. There's a couple scanner functions that we can do. But before I do that, let's look at how much the parts are and how much labor time it is to replace it. So engine mount, side front engine compartment, side and rear of engine compartment, $378 and $387. So it's about a $10 difference between the two, or $9 difference between the two. The front one looks like it's harder to do, 2.8 hours, and then 1 hour for the rear and 1.1 for the side. So there's my hours there. And it looks like even a D-Tech can do it. It's just a few bolts and a plug, I suppose. It should be fairly simple to replace. So let's look at the scanner function. So by the way, in this class, we're not doing any guided component tests. So I always get asked, hey, is this stuff that my scanner can do because I don't have guided component testing? Yes, you can. As long as you have a Snap-on scan tool with the up-to-date software, you'll be able to do everything that I'm able to walk through on this simulator on a real car. So if we go into this Honda Pilot, and we got to scroll down a little bit because we got all our different selections kind of categorized here, in the active control mounts under steering and chassis. So we go in there. It's going to say it's in simulation mode. We got codes, we got data, we got freeze frame, we got functional tests. So if we go into functional test, what can we do? We can reset the system. We can do an actual test of the system. We can turn the individual solenoids on and off, and then we can do both front and rear at the same time, on and off. That'll help us with any testing that we might need to do with the vehicle. We go back and look at data. We can see what kind of data we can see from the module. So like engine speed, control relay, supply voltages, etc. So not a ton needed, not a ton coming out of there. So we got our different current values. So that's active mounts. Let's go to the next one and see if it works. This didn't work in my first class. It's just kind of sad. So let's see if it works. Because of course it worked right after when I tested it right after class. So let's see if it works. It's the simulator that does it. Going to give it a couple seconds. If it doesn't go, it's not going to. And of course it went after, but I'm not live. So that's always what happens. Worked perfect in rehearsal. All right, that was not going to work. Well, let's go to the next one in line. So we have the Nissan Leaf. So Nissan Leaf has the VSP, or Vehicle Sound for Pedestrians system. So we'll go into the scanner and see what we can do there. This one should work. There we go. Okay, so if we got to go down a little ways because there's an electric vehicle where it's going to be under the electric vehicle system. We have Vehicle Sound for Pedestrians right there. Sim mode, continue. Okay, and you see we got codes, data, functional tests. We have actuator tests and special functions. So special function is going to be the VSP sound pressure level change. So if you read up on this, Nissan says you got to bring it back to the dealer if you want to change the volume, because that's a dealer tool function. But of course, we have it here as well. So this function is used to change the output sound level of Vehicle Sound for Pedestrian system. After adjusting a sound level, will be automatically saved after exiting. It continue to adjust it. So we're going to go from the default factory setting plus 1 dB, 2 dB, and 3 dB. Probably going to hear the plus 3 dB. The other two you might not hear much of a difference. So that'd be if it was boosted, you could bring it back down. Can't make it any lower than the default though, because as we said, that was a mandate from multiple countries. Depending on what country you're in with these systems too, you either can turn it off or you can't. Depends on the laws of the country. So in this case, on the US model anyways, it has an off indicator. So that means we have a button that we can turn it off. And then we have a function for the speaker as well. So that's just going to turn it on or off. And it makes the noise. That's all it's going to do. But it'll allow us to test and see if the controller can turn the speaker on. So that's the vehicle sound. Next one's going to be this Grand Cherokee with active noise canceling. So that has that active noise canceling speaker in there. So we're going to hit continue. See if this one works. This one's got to go through security link too. Might be striking out on my simulator today, huh? I'm just running it too hard today. Let's try going in this way. There we go. We'll do a 19G. There we go. Going through security link. There we go. Unlocked. Okay, so we see everything's available. It's unlocked. So we need to go down to the audio system for the active noise canceling. So we got codes, data, system test, and miscellaneous functions. So system test is going to give us a tone test, an output short test, a microphone tone test, and a microphone output short test. So as we said, we got microphones in the vehicle, one in the front, one in the back, and then it's going to output the noise cancellation from the speakers itself. So you'd be able to see that. I don't know if I'm going to get an error on the simulator. Procedure allows the user to check the status of each individual output channel active noise cancellation system. Check for DTCs when it's done. I don't know what it's going to do. It's going to give us a test. We'd probably be hearing something if we were actually hooked up to a vehicle. And then it's going to give us our output readings as well to see how much it's outputting. So it gives us that choice. So that's your active noise canceling system. let's try the last one. So this one was really interesting. Let's see if this one will activate. So this is one we didn't talk about, but it's related to seat heater, ventilated seat, and so on. So this is on Mercedes, and we'll see if this one works. Of course, that one worked out of class 2. And if it won't get in the scanner, we can at least go in this. So let's go into shop key. 2017 Mercedes-Benz convertible. Got to be a convertible for this system. And this is so obscure, unless you're a Mercedes person. We don't even have any search results. We got to go through the service manual to find it. So it's in with the seat system. So it's called the air scarf. And it's pretty much exactly what the name says on the tin. So it is a scarf for your air, or made of air, that comes out. So let's see, where we go. The air scarf function allows the neck area of the driver or the front passenger to be ventilated with warm air at 3 heating levels. The warm air comes out of an opening below the head restraint. The air scarf control unit actuates the air scarf function depending on the following variables: selected heating level, outside temperature, vehicle speed, and soft top status. So the whole reason they came up with this is so your neck doesn't get cold when you're running with the top down. It's going to keep your neck nice and warm. It's going to be like a nice warm scarf for your neck, but it's made out of air instead of fabric, right? So really interesting stuff, and there's way more weird esoteric stuff out there that I just don't have time to cover on everything on that. But I just really think that was it's kind of interesting that even has to exist, or that it does exist. But I guess if I'm going to pay the amount of money I'm going to pay for a Mercedes, I want my neck to not get cold when I'm driving around with the top down, right? I guess it makes sense. All right, so that's my time for this evening. Hopefully you got a couple tips and tricks, and maybe you learned some stuff that you didn't even know existed. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.